Hello, so today we'll talk about a couple examples and the mechanisms of carboxylic acid, synthesis of carboxylic acid, and their derivatives. So to start out, we'll start with a simple Fischer esterification, and that will include carboxylic acid here, plus HOCH3. When using, when you protonate or we'll use H2SO4, and that will create this product. So now we have to ask ourselves, how did this happen? And I'll show you the mechanism for this. Mechanism will go plus, actually, sorry, we have CH3, and we have this H2SO4. So the oxygen will pick up the hydrogen, causing CH3 to have oxygen to be positive. However, this also then allows this carboxylic acid to come in here, and its electrons can take an oxygen, getting it back to a neutral state. However, this causes the carboxylic acid to now have a positive charge. This will get interesting. The oxygen, now free, can bind to the carbon, which pushes this double bond onto one of the bonds onto oxygen. This creates this, where we still have a positive charge on one of the oxygen atoms. So from there, you can use any nucleophile, probably like a good acid. We'll put A for short. And this acid will take one of the hydrogens, particularly this one, allowing the oxygen to have two pairs of electrons. That will produce O and a minus. From there, you can use another HA, where this oxygen can take another hydrogen, break the bond, creating H2O, oops, sorry, that's this is an ether on back up here. Ether, and you still have OH here. So now we have to find a way to get this water off the chain. So we can take one of these pairs of electrons, put it onto, create a double bond. By doing this, we could take off this bond and put it back on water, taking water out of the compound. So through that, we now get this. Still, we have another positive charge. So To alleviate this, we'll use another nucleophile, probably a stronger acid, that will go and attack this hydrogen, allowing to get the oxygen back in its neutral state, producing a final product of H2O and this. So this will be our final product. Moving on, we'll do an example of, let's see here. We can do some synthesis of converting carboxylic acids to ketones. So, conversion of carboxylic acids to ketone. So, the standard way that we'll do this is just take carboxylic acid, it's a two-step process. So we'll first use CH3 and let's say Li, and now we'll need two equivalents of this. And we'll use H3O plus as our second option, and that will produce ketone. So let's take a look at the mechanism for this. To start, we'll take our carboxylic acid and our CH3, or methyl lithium, and this bond will attack the hydrogen, taking it off the oxygen, allowing oxygen to be negative. From there, as I said, we have two equivalents of methyl lithium. So we'll take another one of these and do the exact same thing. However, this bond will not target the oxygen, but it will actually target the carbon atom, bumping this double bond into a single bond and putting a pair of electrons onto this oxygen. By doing that, we now have this structure. So we have both of these are minus. We have lithium plus, lithium plus. Now, we'll use two equivalents of H3O plus, which will essentially just protonate these oxygens, producing now we'll hydrate these alcohols by using another H3O plus, and that will essentially do is we'll only hydrate one of them. So we'll take this one, so we'll have H2O plus, and now because of this positive charge, we need to find a way to take the water out once again. So with these two lone pairs, we'll create a double bond, which will essentially allow this bond to be taken out and put it on the oxygen. This creates this product. However, because of this, the oxygen needs to be protonated. We'll then take H2O or H3O, whatever works. We'll take H3O, and it'll bond and take hydrogen, creating the final product, of oh wait, sorry. My bad. No, sorry. We'll use H2O and we will get a product of this. R. So next we'll do a reaction synthesis of carboxylic acid and acid chloride. So reaction of C and acid chloride. And this reaction starts with another carboxylic acid, where we use SOCl2 to create this using another carboxylic acid and pyridine. To create a final product of anhydride. So the mechanism for this is, once we have the chloride on it, we'll take our carboxylic acid and put one of the lone pairs, target the carbon atom, bumping off the double bond and putting a pair of electrons onto this oxygen. From there, now we will have negative on oxygen, we still have Cl, we have our OH, and then we still have our carboxylic acid on this side. Problem though is that now this oxygen is as a positive charge. To alleviate that, we can put one of these lone pairs onto this bond, creating a double bond. We can kick off this chloride or chlorine. So that can be expressed as minus Cl, producing this structure. Still has a positive charge, but with pyridine, can pick up this hydrogen, put it on the oxygen, allowing us to get a final product of this. And boom, we got it.